Hello everyone, welcome back to Kailash Learning Point. Today I am going to teach you how to make a ray diagram for concave mirror and convex mirror. So in second video already I have explained the rule to make a ray diagram for concave mirror and convex mirror. So same rule I'll apply here to make a ray diagram for concave and convex. Now this is a concave mirror and this point is called pole and this point is called curvature, and I'll get one center to this pole and curvature. I'll get one focus here. This is called focus. Now I have made here two concave mirrors. See here, one is this also concave mirror and this also concave mirror. Why I have made two concave mirror? Because concave mirror forms two type of image. One is real image, another is virtual image. Concave mirror can give real image as well as virtual image. But when you will get the real image and when you will get the virtual image, it will depend on the position of the object. Remember, whenever you keep the object in between pole and focus, in between pole and focus, if you keep the object, then you will get the virtual image in concave mirror. Other than this, if you keep in between focus and curvature or beyond this curvature or from this point left side, wherever you keep, always you will get the real image. Only when you keep the object in between pole and focus, then only you will get the virtual image. Remember this. And virtual image you get always right side of this mirror. This is left side, and there, that in that side, right side, you will get the virtual image, and real images are always from left side of the mirror. Now we keep object in front of this mirror. Now suppose I'll keep this object here. Suppose now I have kept object here, means I know that image I'll get, that is virtual image. Why virtual image? Because this object is not in between pole and focus. Only in between pole and focus, if you keep the object, then only you'll get the virtual image. Now this object image will be real. Let's draw now. Now in that rules already we have learned that when a ray goes parallel to the principal axis, when a ray is passed parallel to the principal axis after reflection through focus, it will return. And in rule number 2, what given? If a ray is passed through focus after reflection, this ray will return parallel to this principal axis. This line is called principal axis. Now this line is parallel to this principal axis. Now when this ray passed parallel to this principal axis, now this is the point of incident. Now this is polished part of a concave mirror. This ray cannot enter here, so it will reflect back, but it will reflect back through focus. And next ray passed from focus, and when this ray will reflect back, it will return parallel to this principal axis. Now listen, wherever these two reflected ray, this is one reflected ray and this is another reflected ray, wherever these two reflected ray intersect each other, there you will get the image. Suppose this is the point of intersection, or these two ray may meet each other in this point, so this is the point of intersection, so here you will get the image. And we know the real images are always inverted image. Inverted means you have kept object in this way and image you have got upside down, opposite. So this type of images are called inverted image. Now this is a inverted image and this is a concave mirror, so I have kept object here, so I have got this real image. So wherever from this point left side, wherever you keep, you get always real image in case of concave mirror. Remember this thing. Now next for virtual image, I'll draw a ray diagram for virtual image. Now same rule we use here. Now if I pass a ray parallel to principal axis, then after reflection it will return through focus, but in front of this object there is no focus, so I cannot pass parallel to the principal axis. Now we have got 4 rule, and in one rule written that when ray is incident at pole, or when ray is passed from this pole, then this ray will return back making an equal angle with this principal axis. I have passed here this ray from pole because in front of this object there is only one point, and that point is pole. So from pole I have passed this ray. Now this ray will reflect back, but how it will reflect back? Making equal angle with this principal axis, and this is called angle of incident, and this is called angle of reflection. Now second rule I'll use for this is I'll pass a ray now from this curvature touching this point. Okay, this is the top point of this object, so touch this point and make one line or ray that you have passed from curvature. So when you draw a ray diagram, use pencil and scale and try to make straight this line. Now I have passed a ray through curvature. Now in that rule already you have got in concave mirror rule, when a ray is passed through curvature, it will return back from the same path. This is curvature, from same path it will return back. It will return back in this way. Now suppose if you extend this line and these two lines are reflected ray, and I have already said that these two lines wherever intersect, there you'll get the image, but these two lines, there is no chance to meet each other if I extend. So what I'll do then, I'll extend backward. In this way I'll extend now this line. Now after extending this line, wherever the ray get intersect, make here one image, and this image is called virtual image, because I have got this image behind this mirror, and in behind mirror you always get virtual image. Here in this concave mirror, why the object image is not from left side of this mirror? Because these two reflecting ray, if I extend, then there is no chance to meet each other. So but we imagine that this ray, if I extend backward, then there is a chance to meet each other. So these images are called virtual image, and virtual images are always imaginary one. So I have used here dotted line. Virtual image, whenever you will draw the virtual image, always remember this line you have to extend in this way. Don't make in this way, just you give dotted line here. Now this image is called virtual image. Now for convex mirror, I'll show for now convex mirror. But in case of convex mirror, always convex mirror gives a virtual image. Remember, here you will not get the real image. So in virtual image, again you think that you will get that focus and curvature are always at right side of this mirror. Now if this is a mirror, now this is the reflecting surface and this is the polished part. So where I'll keep the object? In front of this mirror. Wherever you keep the object, here always you'll get the virtual image, and virtual images are always from right side of the mirror. Now in convex mirror rule, what said in that rule? In rule number 1, when a ray is passed parallel to the principal axis, this is principal axis, when a ray passed parallel to the principal axis appear to diverge from the focus. Now this is a diverging mirror, and this concave is a converging mirror. Now this convex is a diverging mirror, so this ray diverges. but appears to diverge from focus. It seems that ray is coming from focus. In this way it will diverge. So use one scale here and then first you extend like in this way. This ray is called reflected ray. Now next, a ray directed towards the curvature. In convex mirror rule written that a ray is directed towards the curvature. Now you just make this dotted line. Now when a ray is directed towards the curvature, then this ray will return back because this is a polished part. This ray cannot enter in this medium, so it will reflect back. How it will reflect back? Along the same path. So in this ray goes or directed towards the curvature and return back from the same path. So this ray you cannot show here because this is the polished part. So just I have imagined this ray goes straight to this curvature. Same thing for this also. This ray goes straight from the focus. Now wherever you'll get these two rays intersect each other, there you'll get the image. Now this is the intersecting point. Now make here one image. Now this is a convex mirror. As I told you before also that convex mirror always gives a virtual image. Now virtual images are always erect. This is erect, and real images are always inverted. This is inverted one. Now this is the big size object, and this object has diminished in a small size. In my first video already I said that convex mirror diminish the size of the object. Object size is decreased to this. This is the ray diagram for convex mirror. Remember, to draw a ray diagram for convex mirror is very easy because in convex mirror you don't get a real image. If you don't get a real image, then wherever you keep the object here, always you'll get the virtual image. But in case of concave mirror, you can get real image also and virtual image also. Remember, virtual image only in one condition you will get when the object is placed in between pole and focus. When the object is placed in between pole and focus, then you will get the virtual image. Now you have learned about virtual and real image. Now in exam, if asked what is the differences between virtual and real image, then from this ray diagram you have learned that virtual images are always erect and real images are always inverted. And also one difference you learn that virtual image cannot be from on a screen, but real image can from on a screen. And virtual images diverges the ray and real images converges the ray. So if this video is helpful to you, then don't forget to like, share and subscribe my channel. So in next video I'll discuss about sign convention rule for concave mirror and convex mirror. Thank you.